Hello, today we're going to go over sex-linked chromosomes, and I'm going to go through the lecture notes that are available on portals. This is chapter 14 lecture notes, and then I'll go through some problems which are found on your genetics sex-linked genes problem sheet, and that's going to be the final problem sheet in the problem pack I gave to you, gosh, almost 2 months ago now. So then we will have completed that. So let's get started with our discussion on sex chromosomes. And I'll go into my slide view here. All right, so what we know about sex chromosomes is that they are the last set of chromosomes. And if you remember on the karyotype lab, that you had to find the X chromosomes or the X and the Y chromosomes. So that's that 23rd set. Everything else are called the autosomes. All right, and we know that the X chromosome is going to be a little bit larger than the Y, and that all eggs carry X chromosomes because females are XX, males are XY. When we talk about traits that are sex-linked, because all organisms have to have at least one X chromosome, those particular traits are going to be linked to the X chromosome only. There are traits that are linked to Y chromosomes, but the X chromosome is the one where we're going to find these sex-linked, or some will call them X-linked traits. All right. Some examples of those are hemophilia. You all that are history buffs know that Queen Victoria spread hemophilia genetically throughout the royalty of Europe. In fact, the last Tsar of Russia, son, had hemophilia. It's a bleeding disease. They can't clot their blood. Color blindness are also related to that recessive gene that's found on the X chromosome. All right, males get one X chromosome. And what we're going to find is that a male is either going to have a trait if it's linked, or they're not going to have a trait. They can't be what we call a carrier. A female has two X chromosomes. So if she doesn't carry that allele, that particular trait, on both X chromosomes, she's not going to show the trait. However, it's like being heterozygous. She can pass that trait on. And if she has a male and they receive that affected X chromosome, they will have the trait. So I'm going to show you this genetically in just a moment using the actual alleles. All right, so again, those females who have recessive alleles only on one X are called carriers. So a woman could have normal vision when we're talking about color blindness, but she's still carrying the recessive allele for color blindness. So we do test crosses to try and determine how this actually pans out. All right, so let me leave this particular PowerPoint, and what I'm going to do now is open up my whiteboard for you. And we're going to do some of these test crosses, but we're going to start with a basic phenotype-genotype chart. So let me go to this particular line. So here's what we know. We know females are XX. Males are XY. So this is a given. When we talk about traits that are sex-linked, we know that a female, here we have, let's put normal. Then we have carriers. And then we have traits. They're going to carry it. So normal for a female would be XX. For a male is going to be XY. A female can be a carrier, and I'm going to use a little hash mark above the 1X. Males can't be carriers. Now, if they have the trait, A female will have it on both X's. A male, if they carry it on that X, they have the trait. It's kind of like a light switch. They either have it or they don't. It's on or it's off. Females can be kind of in between. They can be carriers. All right, so that's what we know. So we're going to start looking at the X and Y's and doing our normal crosses. So when we set up these traits, we're going to use the X's and Y's and show where these traits are attached to the X chromosomes and how they get carried. So if I move to my, let's see if I can move to the next page. It's not going to let me. Maybe it will. No. All right, let me just erase this. All right, now let's do some problems. So I'm on problem sheet sex-linked genes, and let's go to problem number 4. We'll skip 1, 2, and 3. So in humans, color blindness is sex-linked and recessive to normal vision. So if we set up our phenotype-genotype chart again, for females, they're going to be XX. They can be carriers this way, or they can show the trait. Let's just leave it that way. They can be this. Males are going to be X and Y. That's normal. Or they can show the trait. All right, there's no in between. So in the first problem, we're looking at color blindness. So we're going to call these hash marks the trait for color blindness. And we got a colorblind man, so we know the man is going to be this. Marries a woman who does not carry an allele for color blindness. And so we set up our Punnett square. So we have the male, and then we have the female. Notice the female is normal, does not carry an allele. And so we do our crosses, and you have to carry that hash mark. So what we're going to see here, if the male is, remember in a male, the male determines the sex of the organism. And so the male can only pass the X to a female. The female is normal. So what we find is the X that he gives is always going to be affected. So what we end up with here are these two are both going to be carriers. And they're both female. These two males are going to be normal. So if we look at the questions, it says what proportion of the couple's children could be colorblind? And we look at this, none of them are going to be colorblind. All right, but what proportion of their daughters could be carriers? And what we see is both of them, so we have 0 are going to be colorblind. All right, so that's letter A. Letter B is 100% are going to be carriers. They're both carriers. And then in the third one, if one of their daughters marries a man with normal vision, what proportion of their children will be colorblind? So let's change this out a little bit. Let me take this part off. And in this case, we're going to use one of the daughters. So we know that the daughter, let's change that to black. We know the daughter is carrying the trait and they marry a normal male. And let's set up the same chart. So we get the female up here with that hash mark, the male here. And what we get is a carrier female, a normal female. We get a colorblind male and a normal male here. And so the question asks, if we got this woman marries a man with normal vision, what proportion of their children will be colorblind? It's going to be 1 out of 4, or 25%. All right, so that's what you're going to be doing. I don't want you to do 1, 2, and 3 on this problem sheet. I do want you to do, we've done 4 together, and you should be able to do 5, 6, 7, 8, and 9. Now, 9's going to be a little bit tough for you, but I want you to work on those. I'm also going to post today a, let's call it a quest on section 14.1 and 14.2. I'm going to post that. You're going to have until 5 o'clock on Wednesday to take that. And I'm also going to leave you an assignment. And that assignment is for over Easter break. You're going to be doing the bioterms for section 12.1. So we're going to go from chapter 14 back to chapter 12, and we'll start working with DNA precisely. All right, so again, here are your assignments. You're going to be doing 5, 6, 7, 8, and 9, and 10. So 5 through 10. All right, use those for practice. You're going to find these on the quest I'm going to give you. I will post a quest on Classroom, and you will have until 5 o'clock on Wednesday to take that. Wednesday, I will be in the hospital all day. I have my oncology appointment, and so I will have my iPad with me, but I will not be available most of the day on Wednesday. So if you have questions, send them, but know that I probably won't get back to you till after 3:30. Take care.